All right, so let's talk a little bit more about these ions and kind of what this all means. Ions and valence electrons. Valence electrons, you've heard me say it before, but valence electrons are the electrons in the highest occupied energy level of an element's atoms. So again, if we thought that this was our nucleus in here, and we had energy levels, right? And we had some electrons moving around kind of like this. If I stopped right here, this is the highest energy level, and therefore there would be 4 valence electrons. The electrons in the highest occupied energy level. It would not include the ones that are closer to the nucleus or the lower energy orbitals. Okay? And again, this kind of goes back to talking about electron configurations and whatnot. But so there's your valence electrons and how that kind of relates. Now, how do we determine how many there are? Again, it has to do with where they're located on the periodic table. So if we look at the elements group number, this is where I like using the US way or the European way of naming the element, the families, rather than using the IUPAC way. I know the IUPAC way goes 1 to 18. It's super easy to remember. But the US way, European way, again, if we look at an example like an alkali metals, the alkali metals are in group 1A. So there would be 1 valence electron. If I look at the halogens are in group 7A. Whether it's US or European, it would both be 7. It would be 7A if it's US, 7B if it's European. But so therefore, 7 valence electrons. All right. I've got a picture of a periodic table right here, and you can see that all these numbers right here, these labels, 3A, 4, 5, 6, 7, 8 going across the main group of elements, representative elements, that's how many valence electrons. These ones in the middle, the transition metals, they kind of do change their valence electrons. So that 1Bs and 2Bs and all that stuff, it does change. You don't want to get too hung up on that. We're going to be really dealing more with the main group of elements. And so that 1 through 8 valence electrons. Okay? Now, ionic bonding follows the octet rule. And the octet rule simply says that atoms form ions to achieve the electron configuration of a noble gas. A positive gets together with a negative, a loss with a gain. And I was just reviewing that just a moment ago. Again here, magnesium, let's say if it's a 2+, with chlorine, 1-. Again, I don't know if I like these colors here. Chlorine is a loss of 2 electrons. Chlorine, that's a gain of 1 electron. When that chlorine gains 1, it's done, it's happy, it's not going to gain any more. But magnesium wants to lose 2. So therefore, that's why you need 2 chlorines, each with a -1, each gaining 1 to match up with that loss of 2 electrons from magnesium. Again, you can think of it as your crisscross method or your least common multiple. But again, ionic bonding follows that octet rule, forming ions to achieve the electron configuration of a noble gas. They're very, very strong. Here's a few properties of ionic compounds. Crystalline solids at room temperature. Basically what that means is they're very, very strong. They have high melting and boiling points, okay? And they conduct electric current when melted or dissolved in water. What I like to draw when I think about this is also just like a little chart here, okay? Let's think of an ionic bond, and I'm just going to make up numbers here. This is not any element in particular. Let's say that its melting point is 200 degrees Celsius, and its boiling point is 800 degrees Celsius, boiling point. That means that, let's get another color here. That means that below 200, it's a solid. Between its melting and its boiling point, it's a liquid. And above, it's a gas, okay? And so high melting points mean that it's likely going to be a solid at room temperature. The reason is ionic bonds are the strongest types of bonds. Very, very strong. So these elements, these compounds don't want to break apart and liquefy or change states to gas as well. So there's your ionic bonds. And we'll move on in a moment.